everyone, Ernie Tech here, and what I'd like to do in this video is get into the workings of our emulator. The way I look at it is this: there's no reason to go into Music SP or into the operating system if we don't understand how the actual emulation works. Because the emulation is the machine. It is the IBM 390 that we are emulating in our computer. It's nice to be able to have it running, but it would be a lot nicer if we actually understood what it was telling us, how it works, what it's doing, because you get a lot better experience. So let's just play with that right now. And before we start here, let me tell you a couple quick things that's really great. First of all, thank you very much for all the attention that this channel has gotten. It's really surprising to me because I didn't expect that. I really expected it to be sort of a personal project, but it's taken off and a lot of people are interested, which I think is wonderful. One of the motivations was trying to find all the information that curious minds like us had about mainframe operation, especially in emulators, about the only thing we get our hands on. And while it's out there, there's a lot of stuff on the internet. It is all over the place, and it is, little labors of love by people who really understand this stuff, but the interconnectivity, the ability to know whether or not it's relevant or even up to date. There's so many things out there that lead you into sort of little cul-de-sacs that you can't get out of. Now, what do I do next? And that was my experience. And what I wanted to do was to change that. What I wanted to do, and I'm doing, is to make it one place we can go to hopefully, enjoy this, have some fun, not get frustrated that we've run into a wall and there's nobody there to help us. So that's the intention. The other thing which was really great is the amount of feedback that I've been getting. Tremendous feedback, fantastic feedback. And one of the things was a gentleman who made a comment that he worked with Dave Edwards from McGill University up in Montreal, who is the father, the creator of our emulator, Sim390. Dave was an expert in Music SP and dedicated to this. And unfortunately, he passed away in 2009. But it's still great to be able to use a legacy system and to sort of honor the person that created this. And I'm happy to do that. So thank you very much. Anyway, let's get back to this. Let's crank up Sim390. And if you have been following along in the first two videos, you'll know how to do this and where to find it from my website. Download it and install it, or just get it running because there's no installation. It's dirt simple. The other thing is that I have not been able to figure out how to make these two screens bigger. I have been able to figure out how to make the actual terminal window bigger. More things to play with, but I'm not sure it's possible. Anyway, here it is. This is Sim390, and this is what you would see if you were operating the real thing. Now, if you are operating an ESA 390, the machine from the 90s, you would see it on a screen. If you were operating a 360 or a 370, you would see it by having a big honking thing in front of you with blinking lights and dials and switches and knobs making all sorts of noises, and you'd be sitting there at a desk with a cup of coffee hoping you don't spill it onto the $1 million machine. But that's not the case here. What we have here is a sort of hideous looking pinkish flesh color, and that is going to tell us what we need to know about Sim390 and what you're up to. All right, let's get into this thing here. CPU running. Well, the CPU starts running the minute you start this thing up. And because it's on auto IPL, it's immediately setting up the operating system, and it's good to go. The CPU is running. It says right there, CPU is running. You can turn it off. You can go over here to stop CPU, and you can turn it off. And you can turn it back on again. Why would you want to do something like that? Well, I think the main reason is for operator interaction. It's for somebody who has to turn this online to fix something or maintain something or solve a problem. They turn the thing off, and if it's part of a larger collection of computers all working to distribute the workloads of tasks, the person at the far end using it, maybe the lady who's working at the enterprise rental car center, she doesn't notice that there's any slowdown or any change. It's working. However, this machine was then taken offline and its resources not available, so maybe there'd be a tiny slowdown notice somewhere. So you take it offline for a need, for a fix, for whatever the purpose is. And if it's by itself, if it's just this machine, then nothing's going to happen. I mean, you can't log in, you can't get any action out of the machine until it's back up again. But if it's part of a bigger collection, a collective working to offload a lot of the work to each other, then you may or may not notice. The wait state. Back in the day when you perhaps had one or two machines and you were working in the data center, a program might say, hey, I need volume XYZ, because on volume XYZ on that tape over there in the library, volume XYZ is where the program I'm looking for or the data that I need is maintained. Go get it. And I can't go any further until you get that tape mounted on the tape drive and, get her going. I have to wait. That's generally what the wait state is, as I understand it. The other thing to keep in mind is that we're learning together. So I have kind of an orientation towards this stuff, the reason why I started the channel, but there's a tremendous amount of stuff that nobody knows because, well, it's like is there one guy who understands the telephone system? Probably not. So there's not one guy, I think, that understands everything, and we're going to learn a lot together. So if I'm wrong, or if you say, hey, wait a minute, I think you got that backwards, let me know, because the purpose is to learn together. All right, supervisor state, or supervisory state, as they say. What it is the gate. It is the protector between the inner workings of the mainframe and every other place that you can play without hurting the big picture. What does that mean? It's like in the PC, logging in as admin, or logging in and saying sudo in Linux. If you don't have that ability, you can't get in and fool around with stuff you shouldn't fool around with. If a program needs to get into the supervisor state, it needs to get beyond the gates that keep it from damaging and getting into things that it shouldn't. So if you are most programmers, they don't have a need to get into the supervisory state, but perhaps a customer engineer or somebody else, an admin, does, and their programs are going to need that. So that's what the difference is between the normal operational state, there's a term for it, I forget, and the supervisor state. So not much of a call for at least our purposes. Now, this is the fun one, the PSW, or the program status word. And the program status word is something that you're going to see here and in Hercules. And what it tells you is the inner workings of the computer at any given time. It may tell you the next address of the next instruction. It may tell you by individual byte location something about the hardware status. For instance, I think 14, position 14, or byte 14 will tell you the wait state condition. There's a lot to know here, and I know that there are lots of people who worked in this industry who know what these all mean, but for our purposes, we would have to look it up, I think. But this is the inner workings. This gives you a view into what's going on with the machine based upon this program status word, by grouping, address, or even by individual location within the sequence. So that's what the PSW, so that gets that mystery right off and clarified. Memory size, in our case, we're dealing with a tiny machine. This is the amount of memory that's set aside for this application, for this purpose, as a user, as the OS, whatever the case is. In a 24-bit system, which was the old 360s and 370s, you only had 16 megabytes, but in those days that was a tremendous amount of state. Of space. Remember when Bill Gates said that he didn't really see any reason for anybody to need more than 640K? Yeah, I think that's what he said, but that's pretty much what he said. Anyhow, if you go to the 390, then the actual 31 bits, because they've upgraded it, improvements over time, then you looked at 2 gigabytes of space. So, big difference. Another quick little fun fact is the way IBM labeled or identified stuff for marketing purposes. The System 360, the 60 was, the computing system of the 60s. The 370 was the computing system of the 70s. The 390 was the computing system of the 90s. And then they went to the Z architecture, and then there was the 3090, and then things just stopped playing by the decade. But that's kind of why there was 370, 360, 390. All right, instruction count, literally a count of the number of instructions the machine has handled. To me, I don't know why this thing isn't like 4 billion characters long, but, whatever. MIPS, the millions of instructions per second, gives you a sense of how hard the machine is running, how much work it's putting into running its applications, its operating system, whatever the case is that it's doing. This is giving you a sense of its workload, its speed. Okay, again, my interpretation as I've studied hard, as I've delved into it, and I think I'm on the ball here, but if I'm not, let me know. Just tell me. I will take the advice very kindly, believe me. Couple of other things to talk about. When you see this console over here, you know that is what you're going to see if you were sitting in the data center somewhere and you were the console operator or the admin. It's going to tell you that the thing is booted. It's going to tell you that it's started up a bunch of things. It's going to tell you who's signed on. It's going to tell you which terminals are available or have been dropped for whatever reason. And in this case here, it's also going to tell you that certain servers, certain TCP or Internet Protocol type servers have been made available to us. Now, what Dave Edwards did is he created this with a number of servers built in. For instance, there's an FTP and a web server, HTTPD, running on various ports. Now, these ports are different than the ports you may normally see with an FTP server or an FTP or an HTTP server, which might be 80 or 23 or whatever the case is. And the reason why they did that, I think, was simply not to step on the toes of other things that were running, and maybe for a little bit of security by putting these things into locations that weren't expected. But in today's day and age, if this was running on a server somewhere on the outside, like on my Nanode running from Linode, you know, the bots out there are going to hit every single port possible looking for some kind of response. So that's not really all that valuable anymore. But nevertheless, there are little servers running on this emulator, which lets us get into it using more traditional TCP things, which is cool, but you know, maybe we want to be really pure. We don't want to do that, but it helps, and you'll see later on why that's very helpful. Okay, so a little further, going to delve into a couple things very quickly. Not a lot of detail because we would be here for weeks or months or maybe years. But you can look into the actual computer and see what's going on in its workings, and its inner workings, and its innards, as they say. And for instance, if you wanted to know what the status of the registers of the CPU were, what data, what the conditions were, you know, what word or what bytes were in the registers, all you have to go down here and do is say registers, click on that. And over here in the console window, it's going to tell you what's in all the registers. Obviously not much. But nothing's really going on either. Things are just sort of static. I'm yapping away here, but the machine isn't doing very much. But these are all the registers in the CPU. Same thing for showing the counters. Now there's a whole boatload of different counters, and you'd have to go into the instructions to see what each one does. Now it does emulate an IBM machine, so they're easy to find. But look right down here, TN3270 server. What that means is that the TN tells me that this is coming in through a TCP port. It's coming in not by the old SNA, but if you were going to connect to this server using a remote terminal, meaning an emulator versus the one that's built in, this is what is doing it for you. This is the actual piece of software that he incorporated so that it can do that. So that tells you that. What other things can we? The subchannel table or the socket table. Look at the subchannel table tells you the addresses of the various ports that your equipment can communicate on, either be a terminal or other things. Maybe a printer if you had it, or something to that effect. That's the ports that are available. And finally, for now, the socket tables, which tells you the local socket and the actual port. Now, for me, it's 000. I'm usually accustomed to seeing 127.0.0.1, but that's also going to work too. I think you can actually call it just localhost, but well, who knows? It follows the same patterns and paths that most TCP-enabled software does. But for our purposes here, we're going to come in locally, which means none of this really applies. This doesn't apply to us, but this applies to us, especially 0F0. But let's see how that works. But that's what the console does. It lets you see everything that the machine is doing. You're talking to the computer innards by the console. And these are the things you're going to see all the time, and you're going to see them here in the Sim390, and you're going to see them in Hercules. So that's why it was important to know what these things meant. and then you can display all the various inner workings if you want to, and learn what they mean as well. But this stuff is important because it is the basis for what other future explorations will show you. There's nothing worse than looking at a piece of software and going, what does this mean? I don't know what this means. I'm lost. Now we're not lost. All right, a little bit further going on here. Let's go over and let's start a local session. Now remember, a local session means that we're coming in through the terminal that was built in by the software, by Dave. This is not coming in off of a TCP-enabled port, but it's still going to have a enabled port to come in on. It just won't be a TCP port. It's called a local port. Model 4, bang. I was able to create a bigger display, and still haven't figured out how to make these guys bigger, but I figured out how to make that guy bigger. All right, there's your Music SP main login screen. And if you hear in the background, I have cats. Ernie is my cat. He's the boss, and he is probably telling me to get to work faster. Excuse me, because that's how he rolls. All right, let's just let's get in here real fast and show you one other thing for this particular video. All right, so here's how you log into Music SP, the operating system. You come in as $000. Tab down to password. The password is CUL8TR. Challenge, as I understand it, and I don't know this is exactly right, but if you were a student and you were given time on the machine, you may be given this number, this long number here. And if it somewhere says, I don't think you're who you are, maybe you put the password in wrong too many times, I don't know. I'm going to challenge you. What's your number? You put that number in that says, okay, you must be the guy because this is the only number assigned to you for this purpose. That's how I understand it. If I'm wrong, please tell me. Anyhow, okay, so the next thing we're going to see at the very top, it says user ID last signed on 11/33 on today's date, so it's been up and running for a while. It's signed on right now at 12:07. It's almost lunchtime. What do I want for lunch? I'll figure that out. Here's the two things that are important to us. Port 0F0 and TCB9. Remember TCB? Wasn't there a yogurt stand in the United States called TCB yogurt? I think there was. Anyway, that's not it. Port 0F0, that is the logical port, the hex address that the connection, this guy right here, is coming in on. This is not coming in via the Ethernet, the TCP. It's not coming in through IP, whatever you want to call it. It's not IP, Ethernet. The old days would have been SNA, and there was... Anyway, you're coming in on this particular port, so that port's assigned to you. If there were somebody else coming in locally, it would be assigned to the next one in the range, up until the limits of how many people are allowed to come in. And that is established by the configuration file and the limits on how many it can serve at one time. But this is an important thing too. The TCP, what the TCP is, it is a control block. The TCP basically says your task, the task control block, your task, you, Mr. Guy who came in, Mr. $000, you have been tasked by the computer with being number 9. And that's how it keeps the processes separate from all the different people that are coming in. Because there is no word irregardless. Or is there? Whatever. Regardless of what port you come in on, it still has to know the tasks that it's assigned and to work on for you. So TCP is basically a task control block. That's your little world, and this is the door you walked in on. Okay, so I think that's pretty straightforward. All right, let's press the enter key. Quick thing to tell you to lead into the next video, which should come out in a couple days. In most mainframes, you're going to be presented with what's called a panel. A panel in mainframe parlance is like a menu in PC parlance, especially in the old DOS days. And back in the DOS days, I had a guy at my office who loved to make menus. It wasn't even his job, but he loved making menus. These are called panels. You can create them on your own. They're shortcuts. They're ways of making things look much more cutesy pie and happy for users. Now remember, Music SP was designed for the academic environment, and it was expected to be user-friendly, more comfortable for the students and the administrators, which of course it was. But you don't have to use panels. You can go, as with any of these operating systems, you can go right out to the operating system command line itself, which we'll do by pressing the X, and it takes you to the command line, a big old black screen. Up at the upper left-hand corner here, it says end and go. And what this means is, essentially, as long as you see the go prompt, that means you can enter a command. So I can enter the command, for instance, dir, like in a DOS machine. And it's going to show me what is in the directory of files that are available to me as user $000. If you log in as a different user, maybe guest, or if you have one assigned to you specifically, you're going to see different things. So they're based upon what your level of access is and where you will wind up. It sounds similar to Unix or anything for that matter, or Linux. One trick, though, one important thing before we end this video to prep for the next one, and that is I have two friends that have been helping me to sort of go through this, to kind of troubleshoot some things. They're not experts at all in mainframe stuff, and so they get a little flummoxed when they don't understand what this thing is doing. And here's what I explained. A terminal and the mainframe is a block system. What it means is that unlike a PC where every time you type a character, whatever the character might be, the computer you're working on interprets that character at the time you type it in. It's an interactive back and forth right off the bat, character by character, but not so much in the terminal world. In the terminal world, you put in the information. The terminal itself is dumb, as they say. It has a small buffer. And the information that you put in, either command or options or whatever you type in there, that is getting sent over in a block of data. And if you don't have your stuff, if you don't have your cursor on the right spot, it may not know what the heck you're asking. So if I go into there and I type in admin, it takes me back to that screen. If I hit the F3 key, it'll drop me out of that screen, take me back up the chain, up the ladder. That's the top of the thing. There's no more panels after that, so it drops me right back into the command prompt. Same thing as hitting the X. See, that's the same thing, right? Let me show you real quick. Now I'm going too far. If I just said X, that exit is really interpreted as the keystroke to take it out to the operating system. There it is. So it's the same thing as if I just hit the F3 key. Pops me out. But that blinking cursor down at the bottom, that has to be there. That should be there. Otherwise, it can get confused and give you error messages, and people get upset. I don't know what it's asking me. Why is it doing that? I'm frustrated. I don't know what to do. I dig it. I understand. So if you're always at the place it expects it, down there below that dashed line, that's where you need to be. Not always, but for the most part. To get out of here, and we'll end this video, you type in off. Boom, you're out. And now if you are just walking into the data center or the library or wherever you happen to be at the university with your cup of coffee and your Danish and your donut and your big honking bag of books, this is what you would see sitting there waiting for you on the computer terminal. And that's where I'm going to leave it. Anyhow, we're at the end. We're at the end of understanding at least as much as we can, for now, probably for the most part, about how you interpret what you see on the Sim390 ESA 390 emulator. And it goes a long way to helping you feel more comfortable, that you understand things and you're not mystified, and you decide to give up on this and go watch repeats of Gilligan's Island. But there's nothing wrong with watching repeats of Gilligan's Island, by the way. Anyhow, there we are. Thank you very much for please subscribe. And thank you very much if you've subscribed. Thank you very much for watching. And I really appreciate the encouragement on this. I like this stuff a lot. Maybe you've gotten to a point where you like it too. Or maybe I've helped you discover that you don't like it. It's hard to say. But nevertheless, I appreciate it. And we'll talk to you soon. Bye for now.